For this video, I know people are going to be struggling a bit because we're going to be doing some algebra. I need you to please look at the examples we're doing, try to follow along, look at how we do all the steps, we show all the work, we're methodical about it. Please follow my examples in regards to this. I would strongly suggest when you're done with this video and these notes to go ahead and give yourself some time to try the problems out again from scratch on your own without looking at the notes, and then go back to review to see if you did it right or not. I can also provide additional practice problems if you need to do so. Just reach out to me. Part A. So we have angle KLU is what we need to look for. We have ULM, so ULM is a smaller angle, and that's 20 degrees. And KLM is 110, so that's this entire angle. That's 110 degrees. So we need to find out what this angle right here is going to be. Now, if we think about this just in our heads, we could say, oh, well, what number adds up to 20 to give me 110? And then you can say, well, that's going to be 90 degrees. Great, good for you. Let me show you the math. So we set up the angle addition postulate we have here, and I have a color coded as well for you to be able to follow along. I have the smaller angle, angle MLU or ULM, plus angle KLU or ULK is the entire angle, the green one, angle KLM. Let's go ahead and substitute what we've been given. So we know that ULM is 20 degrees, and we know that KLM is 110 degrees. And we don't know what KLU is, so that's what we're solving for. We're going to go ahead and we want to get this by itself. Don't be scared that you see 3 letters. We're not solving for each letter. You can pretend that this whole thing is just x, right? So if you want to pretend that this equation is actually 20 plus x equals 110, if that helps you, then that's what we're doing. We're just subtracting 20 from both sides, and we get x equals 90 degrees. Okay, so in this case, we're not solving for x. There are no x's in here. I don't want to get into the habit of x's. I just want to let you know that you can treat that as one variable. So I subtract 20 from both sides over here, 20 degrees, and I get that angle KLU is equal to 90 degrees. Now, the interesting thing here is that even though they didn't mark it with a square, we know that this is a right angle. How do we know it's a right angle? Because the angle measures 90 degrees. Okay. Let's go ahead and set up the angle addition postulate for this next one. So we have EGF plus angle HGE, so the 2 smaller angles, they add up to the larger angle. We can go ahead and substitute what we've been given. This is a bit more algebraic. So EGF is 110. HGE is x minus 30. HGF is 2x plus 25. These are very popular problems on the Common Core test, on the NWA benchmarks, on the SATs, on the ACTs. So let's get this really good, because it's going to pop up many times. We went ahead and just substituted. So we haven't done any math yet. We've just recognized our shapes, how they relate to each other, label them correctly, express how they are related to each other, and then we found out, oh, they have different names. Let's go ahead and call them by their different names. And so we went ahead and substituted. That's what calling it by a different name means, substitution. And now we are here at this point where we're ready to do some math. Okay. If it helps, let's do 110 minus 30. That's on the left side. So there's no need to do opposite signs. If we're on the same side, we just combine like terms. So that becomes 110 minus 30. That's 80. It's when we move things around on the opposite side of the equation where we do opposite. So for example, if I'm going to subtract this 25 from both sides, then I'm moving it to the other side of this equal. If I'm moving into this side, I'm going to do the opposite. I have a plus 25, so I'm going to subtract 25 from both sides. Oops. Okay, so we get 55. Don't forget the plus x equals 2x. I'm not skipping steps. I'm showing all my steps. You too can do these problems if you have good habits. Good habits means don't cut corners, write everything down, account for everything in every step of the equation. Now, I want to get the x by itself, and I have two of these, so I need to go ahead and subtract this from both sides. I need to move it over here. So we get 55 equals 2x minus 1x. That's just 1x. And we don't need that 1 there, so we get that x is 55. Now, please be aware, this problem asked us to find x. It didn't tell us to give the angles, the measurements of the angle. So we did not find the angle measurements. All we know so far is that EGF is 110 degrees. None of these other angles is 55 degrees. We found x, not the angles. So if we wanted to find the angles, it would have been HGF and HGE. Okay, you could find the angles if you want by taking this 55, plugging it into here, and plugging it into here. We will do that on the next problem. May I suggest trying this one out on your own, maybe pausing this video, setting it up, seeing if you can set up the angle addition postulate, seeing if you can substitute correctly, and then maybe if you need some help, see what I'm going to do in a moment. Pause, try it out. So by the angle addition postulate, we can express VUJ plus angle JUT is this entire VUT. Okay. We should substitute what we've been given. So VUJ is 17x minus 3. JUT is 17x plus 8. And then VUT is 175 degrees. Now, y'all passed Algebra 1. I don't know. All I know is you pass it. I don't know. You pass it. So we are doing some algebra here. And actually, we're doing technically pre-algebra. Okay, so it's okay because you passed pre-algebra and algebra. You got this. We're going to go ahead and combine like terms. So this 17x, this is an x term, and this is an x term. And for example, this is a number, and this is a number. And we're going to combine them because they are on the same side. I don't have to switch. I don't have to do opposites. I don't have to do, the opposites of like we did in the past problem. Yet, we're on the same side of the equation, so we're going to go ahead and just combine like terms. So 17x plus 17x, that's 34x. And then negative 3 plus 8, that's a positive 5. And on the right side, I have an equals 175. Now, we want to get this x by itself, so this becomes a two-step equation, is what we call in pre-algebra, where we move something over by addition or subtraction, and then we end up dividing. I want to move this 5 over to this side. I get 34x equals 170. And then we currently note that this 34 is being multiplied by this x, so I'm going to divide both sides by 34 to get the x by itself. Upon doing that, we get that x equals 5. Now, this problem is different because it says find x and give the angles. So, let's show you how to get those angles. So, recall from this problem that VUJ is 17x minus 3. I'm going to just write that down, and I'm going to go ahead and erase the x and put parentheses. And guess what goes in there? 5. We do order of operations, so we don't do 5 minus 3. We do 17 times 5, which is 85, and then we subtract 3 from that, and we're going to get 82 degrees. So we know that VUJ is going to be 82 degrees. That looks believable because, it almost looks like a right angle, which is almost 90 degrees, right? And let's do the same thing for angle JUT. Everywhere where there was an x, I erased it. I'm going to drop in that 5 that I found. 17 times 5 was 85, plus 8 is going to be 93 degrees. Please use calculators. I am so for using calculators. So we find that angle JUT is 93 degrees, which makes sense. It's obtuse, right? It's a little bigger than 90 degrees. Great. Now, you can always check to see if you're completely correct, because this plus this, according to your angle addition postulate, should be equal to 175 degrees. Okay, so that's not part of the problem, but you can always check to see if what you have makes sense. Here are many, many, many angles. Let's go ahead and write a few possible configurations. If you'd like a good practice and good preparation for you, would be to write every possible combination you can think of with this image. So let's start off with, for example, angle LXO plus angle OXV equals angle LXV. Right, LXO is this one right here. OXV is this one right here. And LXV would be the combination of those two that would form this larger angle. Here's a bigger one. So I'm taking OXV, this angle right here, VXE, this angle right here, and EXR, this angle right here, and saying that that is OXR, so this entire angle right here. We can do more than two angles, right? Like we do a segment addition postulate. So here's a super angle addition postulate. So this is if we're doing all of them, making the claim that if I add this one plus this one plus this one plus 2, 3, this one plus 1, 2, 3, 4, 5, that one, that ends up being this entire straight angle essentially. Okay. Now a couple of things I want to bring up that maybe you're wondering and starting to notice. Each time that I label a different angle with a little curve, a little arc, I add more and more if they're different. So if they were the same angles, this would be like all single arcs. But because they're all different measurements, I kept adding more and more arcs to distinguish them as different angle measurements. Also notice something, that whenever I did this angle addition postulate for any of these cases, note how somehow magically the vertex was always in the middle of all of the angle names, right? So don't forget that. Okay, it just worked out because we did it right. For your summary, what's the difference between solving for x and solving for the angle, and how does one lead to the other? And again, I would strongly suggest after this, go back, try these problems out again on your own, and reach out to me if you'd like to try more problems out.